Hey, welcome back to Decimals. Remember part one of real numbers was fractions, and now we're going to look at decimals. Hey, how much do you know about decimals here? Hey, maybe this little summary down here might remind you of some things. We've got a decimal point, and we've got whole numbers on this side, and tenths and hundredths over this side. Let's investigate this system and where it came from. It's interesting stuff. Now around the outside, right around here, you can see some numbers split up into various forms, fractions and decimals. And I want you to look around there. There are 4 little groups there that are the same, and 3 other numbers that form a group which are also the same as each other. Can you pick them out? It shouldn't be too hard. It might be a little bit of revision for you to see how much you remember of tenths, hundredths and thousandths. So pause the presentation and see if you can pick out which ones are the same and which ones are different. All right, let's have a look. Here's 4.63 over here. And what does it mean? Oh, 4 and 6 tenths and 3 hundredths. Did you get that one? Let's look for another one with a 4 in it. Hey, come down here, down the bottom here. 4 and 63 hundredths. Yeah, that's the same. Do you know why though? And over here, 463 divided by 100. Oh, working with decimals, you've got to remember some stuff, eh? We're going to have a look at easy ways of remembering it in a minute. Let's have a look at 14.062. Okay, over here, right over on the left here, 14 plus 6 hundredths plus 2 thousandths. Do you get that? No tenths in that one. And what about down here? 14.062 divided by 1,000. So we're bouncing between some fraction work and decimal work. Decimals, what do they mean? Come on down and see how handy this is as a short way of writing numbers. So a decimal number, or just a decimal, refers to any number written in decimal notation. More commonly used to refer to numbers that have a fractional part separated from an integer part using a decimal point. Okay, so it's a more convenient way of writing a number rather than the mixed number 13 and 95 hundredths. Okay, that would be the fractional way, or mixed number way, of writing this number that we've got here. So let's just revise it now. Okay, the number there is tens, this is ordinary units, this is a tenth of a unit, and this is a hundredth, and so it goes on, a thousandth and so on. Decimal, ever looked at that word? It's got dec in it. Hey, give me another word in the English language that's got dec in it. What about decade? Meaning 10 years. Hey, this dec is associated with the number 10, isn't it? From the Latin. Okay, decagon, 10-sided polygon. Okay, so we use it quite a bit. Now that's the roots of the word there. Got something to do with tens, if you like. Tens, hundreds, or a tenth, a hundredth, 1,000. Why did they do that? Why go to a system with a base of 10 or base 10 or a decimal system? Now money is a decimal system too, isn't it? 10 cents and a dollar, etc. Okay, so I think there might be a clue on this screen. Hey, pair of hands, count the fingers, mate. There are 10 fingers. And this is thought to be, it's not definite, this is thought to be the origin of the decimal system. The idea that you can use your fingers for counting, and there are 10 of them, making that the base unit. Base 10 is sometimes what we say. See that later on. There are other systems of counting where you don't use base 10. There's something called the binary system. Binary system. Okay, bi. Oh, using that, not dec. And bi means two, bicycle, 2 wheels. So there's a binary system where the base unit is 2. Well, you might see that a bit later on. Not in this course, a bit hard for this course. Let's come down here and have a look at these fractions along this line here. And you can see our problem, I think, in using the decimal system. What is a half? Well, a half is cool. It's 5 out of 10, that's an easy one. A quarter, oh, we've got to change it to a decimal system, a base 10, don't we? So we need to have that as 25 out of 100. So all these fractions, if you're going to use a decimal system, have to be converted to either tenths, hundredths or thousandths. So you've got to keep going until you get an exact answer here, if you like. Is that always possible? I don't know, you might have had some experience with those where the decimals don't stop. We're going to look at that in a later presentation. But this is 125 over 1,000. Okay, because 125 goes into 1,000 8 times. So we could cancel top and bottom. We did that in the last presentation. So 1/8 is 125 over 1,000. So there's our first problem of changing our mixed number into an integer. That's okay. But on that right-hand side after decimal place, can you change it into tenths, hundredths and thousandths? There's a challenge for you. So come down here and let's have a look. There they are, done for us. Just remembering this system here is summarising it for us. Okay, so 5 tenths is 0.5. The tenths are in that first spot after decimal point. That's our system, our nice, neat little base 10 system. Okay, that's the reason for that. And then 25 hundredths, we changed a quarter to that, is no holes. So we always put the 0 in front. Sorry, I didn't mention that over here. And then it's 25 hundredths. Okay, in here, hundredths. Okay, 1/100th on that last point there. And 1/8 is 125 thousandths. 0.125. Now, how do you remember this? Okay, now we want to understand what's going on. So it's a system based on 10, and we're going to develop some rules. So once you've understood the system, and we're going to do this, I think you've seen this before, Huddy's hierarchy of learning. What is the algorithm or the rule which you use to remember the problem? But please remember, come up here, don't just use rules, use concepts and get to the top here, and I see it. Okay, the algorithm is the memory work of what to do, but it's important to say, do I understand it? Can I go up close and personal with math here? So I'm going to give you the algorithm, but we've just done the important part, trying to understand the system. That's what we're doing. Do you see some of our dilemmas here of changing a fraction to thousandths or tenths or hundredths, something based on a decimal system? Okay, I'm going to give you the rules now, and just as long as you remember what's behind the rules, that's important in maths. Okay, come down here now, and let's have a look. How do you remember? How do you remember how to do it? The algorithm, the rule. Okay, so here we are, 13.956. Don't ask me where I got that number from, but there it is. It's a good number, isn't it? How do you remember what all these things are? Put 1 for the decimal point and a 0 for each digit after it. So here we are, let's do the 9. Call that 1, so that's 9 tenths. Do the 5. 1, 0, 0. 5 is hundredths. So you would have 95 hundredths, okay, because 9 is tenths, and there are 10 tens and 100, so there'd be 95 hundredths. And out here at the 6, that would be thousandths, so there'd be 956 thousandths. Just remember now, bouncing between these, here this has got a tenth of this one, so 9 is 9 tenths or 900 thousandths. Okay, so this is the biggest one, less large as we go here, and 10 of them make up the previous one. So there, here you've got the successive one. Sorry, 9 is 10 hundredths. 9 tenths is 10 hundredths, and 5 hundredths is 50 thousandths. Okay, so just remember the separation as we go along there. A tenth to a hundredth to 1,000. Okay, so 1/10 has got 10 hundredths in it, going from here to here. 1/100th has got 10 1,000ths in it. Right, it can be shown with cancelling, going top and bottom by 10, and so on. That's our decimal system, and using that decimal dot there, that decimal point, to actually indicate that. So that's how it all works, but here's the rule. Put 1 for the decimal point and 0 for every digit after it, up to the one you're interested in. Now, I don't know whether you've seen that. I hope you've seen a bit of this stuff, but if you haven't, now's the time to get on board, because we're starting from the basics now. Okay, come on down and let's have a look at some examples. I'll get you to do some work in a minute. Right, 5.704, an expanded fractional form. Okay, so that's 5 units, 7, what are they? They're 7 tenths, using 1 for the decimal, 0 after. Oh, there's no hundredths, but there are 4 thousandths. Just remember, 1 for the decimal and 0 for every one after. So when you get out to the 4, that's 4 thousandths. Really trying to understand our base 10 system, and that's all it is. It's supposed to be a neat way of writing fractional parts in numbers. What about this one? Right, 3 plus 2 tenths plus 4 hundredths plus 10, 1 10,000 in decimal form. Well, there they are. That's 3, first place after decimal, second place, third place, isn't it? Using our system. Get familiar with what these pieces mean. Okay, now what about this? State the value of the digit 6 in here. Well, let's go out to 6. 1 for the decimal, 0 for each part. It's 6 thousandths. Okay. All right, so have you got the idea? I'll do a couple more and ask you to do some in a minute. Okay, so come on down here. Converting decimals to fractions. Okay, we've got to go backwards. And remember here, this little dude's saying, write your answers in lowest terms. So 0.6, 1 for the decimal, 0 after, 6 tenths. But we can divide top and bottom by 2, so you get 3/5, or called cancelling, isn't it? Sometimes we just write 2s into 6 go 3, 2s into 10 go 5. We do the same to top and bottom line. We keep the ratio the same, the meaning of the fraction. That's called an equivalent fraction there. It's equivalent to the bigger one, bigger numbers, the same size fraction, 6 over 10. Okay, what about this one? 0.045, 1 for the decimal and 0 for each number afterwards, 45 thousandths. Just remember, this is 45 here. There are 10 of those hundredths in 1,000, so it's 45 thousandths. Divide top and bottom by 5, 9 over 200. Okay, right, so you get the idea, because I'm going to ask you to do some of these in a minute. Here's an interesting point. What do numbers in decimal form look like on a number line? Okay, so here's just starting at 0, the positive direction of the number line. Point 2, what will you do? You'll divide the line up into the digits, to the size of the last digit there. So these are tenths, aren't they? Now, it'd be hard if we had 0.04. You'd have to divide the number line up into 1 for the decimal, 4 hundredths. They'd have to have little hundredths in here. Oh, hard to mark that out. So these are tenths. But get the idea here, 2 tenths. And this is 9 tenths of the way to 1, 0.9. 1.3, 3 tenths past 1. 1.8, 2 tenths short of 0.2 if you like. So you get the idea, the number line to the rescue here to understand what's going on. And just remember, of course, we're doing directed numbers these days. We've got positives on this side, positive, and negative on this side. Let's take neg 0.9. It's 1 tenth back from neg 1. Get the idea. Study that number line a bit, because which is very important to have a look at that. All right, so let's have a look now at rounding. Now, I don't know whether you've seen these rules. These are certainly little rules that I don't want you to follow and just copy. Monkeys copy each other, so I call these monkey rules. But here, I don't want you to just do that. I want you to say, hey, Huddy, why does that work? I want to get up close and personal with maths. Okay, because then it's fun. Okay, here's the rule. If the digit after 1 being rounded is less than 5, we round down. If it's 5 or more, we round up. Well, first of all, what's rounding mean? Rounding. It means you're going to, if you like, shorten the number of decimal places you're using, because some people might say, well, I don't want it that accurately. I don't want 1.8. I want to know it to the nearest whole number. This nearest idea is what we mean by rounding. We want the decimal or the value to some specified degree of accuracy. We don't want a 1.8. We want to know, is that closer to 1 or 2? We maybe want to work in wholes. Or you might want 1 decimal place, 1.84. I don't want too much. I can't measure that accurately. I just want it to 1 decimal place. Like your marks in a test, converted to a percentage. The teacher will usually round to the nearest percentage. Okay, when you put it out of the total and times by 100, you might have 92.4, you wish, percent. And that would be rounded to 92, wouldn't it? Rounding, getting to the nearest value according to whatever level of accuracy you want. So let's do some here. Let's see why this rule works. Let's take 1.3 and I want it to the nearest whole. Here is 1.5. Now have a look. Is it closer to 1 or closer to 2? So this is why the 0.5 is definitive. 0.5 is equivalent to halfway. So if it's halfway or less, now this is interesting, if it's on the 1.5, we round it up. 5 or more. We round it up. Really, 5 should stay there, shouldn't it? It's exactly halfway. It's neither closer to 1 nor 2. But we choose to halfway go up. Okay. Now, 1.3, it's less than 5, so it's actually closer here to 1. So we would round that down to 1. 1.8, well, 0.8 is bigger than 5, so it's more than halfway, so that's actually closer to 2. So we would round that to the number 2. That's the idea. And the 0.5, come down here, less than 5 in that next place, is the halfway measure. Okay, because why is it 5? Why is it 5? Oh, I know, decimals. There are 5, 0.5 is halfway between 1 and 2, 1.5. And between any decimal points here on our decimal scale, our 10 scale, is going to be 5s, isn't it? 5 will represent the halfway mark between the tenths and the hundredths and so on. That next decimal place is halfway to the tenths, to tens. Okay, do you get the idea? We're going to come and do some in a minute. So let's have a look and see what you think. Round 39.748 to the nearest whole number, because people say, hey, I'm getting confused with all these decimals here, mate. Just give me the nearest whole number. Well, what will you do? Well, let's draw this one. Just give me a bit of space down here. So let's go and have a look at 39.748. 39.5, 40. Okay, 0.748. We want the nearest whole, so let's look just at that one. 748. So it's over this side somewhere, isn't it? 39. It's past the 0.5 halfway mark, so it's actually closer to 40. That's how it works. First decimal place is 7, so round up, because we're doing the nearest whole. What about to 1 decimal place? Now, we want this to be as accurate as possible. So we look just at the next decimal place. Let's draw that one now. This is 39.7, and we want it accurate to the nearest decimal place. 39.8, and the halfway mark, halfway between 0.7 and 0.8 tens, is 5 hundredths. 0.7 is 7 tenths and 8 tenths, and there's 10 hundredths between them. So you've got 5 hundredths, that's a halfway mark. Now where's 39.748? Oh, just in here. 39.74, we look at that one. It's just inside there, 39.74. You look at the next decimal place, and it's 4, so round down. So the answer would be 39.7. Let's do the last one. 39.748. So let's go 39.74. We want it to the nearest second decimal. 39.75. So the halfway mark between these 39.745. Remember, there's 5 hundredths, 5 thousandths, sorry, between 0.4 and 0.5. Okay, so that's our halfway mark. All right, so what is this number? 39.74, and there's an 8. So this is in here somewhere. 39.748. It's probably a bit closer up here, isn't it? That's 5, 8, somewhere there. So it's actually closer to this end. So it's 39.75. So there's our rule, but here's how it works. Remember, don't just apply rules. Try to remember how they work, and that'll make it a lot easier actually to do maths and not have to purely remember everything. All right, have a look, go back over that. That rounding up stuff is very important, but so is why does it work? Why? Always ask your teachers why. Okay, come down and let's have a look now at doing some. I want you to go through all of those, and here's the first 5 questions, so pause the presentation and have a go, and then I'll scroll on and show you the answers, and you can scroll forward and back just to check as you do a problem that you get it right. Don't do them all to find that you're getting them all wrong. Do not perpetuate an error. Okay, let's have a look at 6 now. 6 and 7. Okay, pause it and have a go. And I'm going to go on now and show you the answers. Okay, just check your answers and see why they are like they are. Okay, let's keep going. You're getting some skills back here. I hope you've seen this before. Doesn't matter if you haven't. Get in on board now. Okay, adding and subtracting decimal numbers. Now, what might be the important thing here? We've got to write the numbers so that the units are the same. Okay, so that means lining up the decimal, 15.3 and 9.26, and then we can just take them away as usual. Okay, look at that 0 in there, just to indicate it's got no hundredths. This one's got 6 hundredths, so we've got to take them away. Sorry about that, that's out of the way. So here, what are we going to do? We're going to subtract, we're going to add, sorry, here. So no hundredths and 6 hundredths is 6. 3 and 2 is 5. And the 5 and 9 is 14, carry 1. Is 24.56. So it's the same idea. Just remember here, you put a 0 at the end to make sure all your units are the same, that the decimal lines up. So it's tens under tens. Okay, tenths. Okay, so that idea, just an interesting little method. All right, let's do some subtraction here, these two being subtracted. Okay, so again, here we are, lining the decimals up, and then do the usual subtraction as for whole numbers. So 7 from 2 doesn't go, we borrow 1 here, and take 1 off there. Remembering there are 10 thousandths in hundredths there. So it's all in tens. We've already done this with subtraction of numbers. So 7 from 12 is 5, and 0 from 2 is 2, 5 from 6 is 1, 4 take 1 is 3. So we've done it. What about this one? 8. Oh, look at all the place zeros there, indicating there's no tenths, hundredths or thousandths. And subtract 0.706. So 6 from 0 doesn't go, and you've got to borrow it from right up here. So borrow a whole unit, so that is going to give you 10 tenths, which you've got to borrow down to 9 tenths, borrow down to 9 hundredths, borrow down to 10 thousandths. So you've got to carry that all the way. So 6 from 10 is 4, and then 0 from 9 is 9, 7 from 9 is 2, and 17 is 7. Okay, so we line them up, put that 0.000 after the 8, so we have the same number of decimal places and the units line up, if you like. Okay, here we are. All of the decimal points must line up, so you keep the units the same. All right, you get the idea, a bit of revision of subtraction there. Okay, so here's your little set of problems. I want you to do it by hand. No calculator for this one. And just make sure you can do the basic stuff there. All right, let's have a look at the solutions now. The answers rather, not the solutions. It doesn't show you how to work them out. They might have to discuss some of this with your teacher and with classmates. Let's go on and see if we can do some multiplying and dividing. Okay, now, first of all, we've got a base 10 unit. So if we multiply and divide by 10, it should be easy. Let's have a look. When multiplying by a power of 10, we shift the decimal point to the right. When dividing by a power of 10, we shift the decimal point to the left by the number of zeros, if you like, or the powers of 10. How does that work? Let's have a look. These are just the rules, so we really want to work out why that's going on. So 0.38 times 10 becomes 3.8. Why? You're making the number 10 times as big. So the tenths become whole units. Okay? And the hundredths become tenths. That's the idea of shifting the decimal. Do you get it? If you're multiplying by 10, you're making one value, or both of them, 10 times as big. So the number 3 shifts off and you put the decimal point to the right. Okay, well, hang on, get rid of this. So 0.38 divided by 10. Hey, that works in reverse. Everything's becoming smaller. So the tenths become hundredths. You've got to shift the decimal place across to the left and it goes there. Okay, so the 3 become 300ths. You're dividing 800ths by 10, become 8,000. So that's the idea of to the left or right by one decimal place, because each decimal place represents bundles of 10, doesn't it? The decimal system. Okay, what about timesing? Okay, you're going to make this number 100 times as big. So the 3 tenths become 30 and the 3 hundredths become just 8 units. Okay, because each bundle here is a bundle of 10. So shift the decimal point to the right 2 places. 10 by 10, 100. And here we're going to make it 100 times smaller. So 3 tenths become 3 thousandths. Got to put the decimal place across 2 places. Okay, because you're making it not 10 times smaller, 100 times. That's 2 shifts of 10, if you like. 10 squared. So you can count up the number of zeros here, because that, again, that's a nice property of the decimal system. 10 is 10 to the 1 place. 100 is 10 squared. So that's 2 bundles of 10 that you've got to consider. So it's 2 places. And 1,000, of course, just count the zeros, is 3 places. Each place representing tens. Why? Because it's a decimal system. Dec, meaning 10 from the Latin. Okay, want to do some. Let's have a look at a little bit more though. We haven't done any multiplication and division of decimal numbers. So to multiply decimal numbers, we multiply numbers as though they were whole numbers, then divide by the appropriate power of 10. Okay, so what are we going to do? 0.3 by 0.15. So 0.3 is 3 divided by 10 times 15 divided by 10. So we'll multiply the numbers together, 3 times 15, and then we have to divide by, what, 10 by 100, because we've made, just taken the top numbers off, so we've still got 1,000 in the bottom line, if you like. So it's 45 divided by 1,000, 0.045. You can do it slightly differently. You can do it hang on, I'll do it the other way up. Okay, 0.3, 0.15, oops, sorry, done it the same way again. 0.15 and times 0.3, call it 15 times 3, 3 5 15, carry 1, 45. Now we had, these were 2 places, 3 places, so it's got to come in 3 places. Okay, so you can do it like that. You might have been shown that. Count up the decimal places behind it, behind each number there, and do the number multiplication, but then remember to bring the decimals in. Or just like this, shifting the decimal place 3 places to the left. 1, 2, 3. Because you've just taken off the 3 and the 15 as if they're whole numbers, and that's not true. So you've got to make them back into tenths and hundredths again, if you like. All right, let's go to a bit of division. Now, division has a rule, of course, 2.7 divided by 0.3, and the rule is to make the denominator the nearest whole number. So you can divide. So 0.3 just times that by 10, and you do the same to the top line. Okay, remembering that if you're doing division, you're doing 2.7 over 0.3, then you can do the same to the top and bottom line of that fraction. So look at the bottom, make it a whole number, do the same to the top. So that becomes 27 over 3, which you can do 3's and the 3 goes once, 3's and the 27 goes 9. That becomes 9. What about this one? Now, the crucial thing here is the bottom line is 0.08. Let's make that a whole number by times it by 100. So you've got to times the top line by 100 as well. That only gives you 0.2. So the top line may not become a whole number, but the rule is because it's easier to divide by integers, you make the bottom line a whole number. Now you have to do your long division here. 0.2 divided by 8. All right, so 8 in a naught doesn't go. Oops, hang on, let's get rid of that. 8 into 0.2 goes 0 times, and then it becomes 8 into 20. 2 8s are 16, carry 1, carry 4 is 40. 8s into 40 goes 5. So remember that division problem. So when it 8s into 2 don't go, 8s into 20, they didn't put that, 2 8s are 16, carry 4. Do you remember that stuff? All right, so let's try that. Here's some problems for you, and then we'll finish up. You've done well. I hope you're getting the idea of things here. Question 1 to 4. See if you can do that division. Bit hard, some of these down the bottom here. Long division you may not be able to do. Okay, pause it and have a go. Okay, and 5 through 9 is the rest of that set. So I hope you're getting some understanding of where decimals came from, what they mean. I'll show you the answers now. There are the answers. So mark your work. I hope you got a few right there. Okay, well, we're going to go on with decimals in another presentation. Next one coming up. So keep practicing. Cheers for now.